Dear student, today we will discuss the dissolving metal reducing process. As you know, in previous many method reduction processes, what is the reduction and how it will perform. So today we are going to reduction process by the dissolving metal. What is the role of metals in the reduction process? In the presence of alkali metal in liquid ammonia, aromatic ring are partially reduced to give 1,4-dihydroxy product. It is known as Birch reduction. So here you can see this is benzene. This benzene can be reduced in the presence of lithium and sodium and potassium metals in liquid ammonia, like proton donor. It means we are using these metals. The final product is 1,4-dihydroxybenzene. So, what is the key step in this mechanism? The mechanism of Birch reduction involve by addition of electron proton take place. Here you can see for the benzene rings, benzene pi electron distributed by both the atoms, the present pi electron present in between. The sodium metal ion give the one electron and negative charge generate in the benzene rings, and further this reaction proceed. The most stable resonating structure is here. So then protons comes in the solvent and form this species, radical species. Then again one sodium metal give one another electron and form this negative charge in the benzene rings. Then another proton comes or form the 1,4 dihydro reduced benzene ring, means 1,4 addition of hydrogen. Effect of substituents. How the effect of substituent present in the benzene ring or other aromatic ring means if the electron releasing group promote ortho and meta reducing, because electron releasing group stabilize electron density at ortho and meta position. Here you can see in the benzene ring located here. So there are two possibilities there. First one is negative charge. One position means negative charge in para position and ipso position. Another one is ortho and meta position. So you can see here when electron withdrawing group is present, then minor major product should form. You can see in this reaction when the electron withdrawing group promotes ipso and para reduction. Electron withdrawing, right? Electron withdrawing groups. When electron releasing group, then product is ortho and meta position, because in high electron density is present in that position. Electron withdrawing group present, then it promote ipso and para reduction, because electron withdrawing group sustain electron density at ipso and para position. Here the stabilized resonating structure, another is destabilized destabilized resonating structure. If we compare both the resonating structure, the first one where the negative charge in ipso position and radical in para position is more stabilized, so the product form accordingly. So you can see electron withdrawing group when we use the sodium metal in liquid ammonia, then major products is this one, right? So there are another examples. When you take toluene, then you can see the corresponding product. When you see anisole here, so sodium metal used for reduction, lithium liquid ammonia, which is giving the proton as work as a proton layer donor and give the corresponding product. So it is clear there are a lot of examples. If xylene is there, orthoxylene is there, then corresponding product is also formed. The resonating structure, the ortho and meta position is more electron density, so corresponding product will be form. There are a lot of examples you can write in a book and discuss accordingly. The another example is the CWH group present in the benzene ring and benzene ring. So if this is electron withdrawing group and form the corresponding ipso and para position get reduced. So yeah, there are some other more example. You can write also the reduction process, the reduction mechanism. So this is another example. 3 benzene ring attached and lithium nickel. The middle one ring is reduced, give the major product here. The reduction of carbonyl compound. Reduction of carbonyl compound means reduction by the hydride transfer reducing agent like lithium aluminum hydride, sodium borohydride, sodium borohydride, and the presence of cerium chloride, Luque reagent, and DiBlH. And we have already discussed the reduction process by the lithium aluminum hydride and sodium borohydride. Another one is electron transfer reducing agent, alkali metal in liquid ammonia, lithium, sodium, potassium in liquid ammonia. Third one is reduction of carbonyl group into CH2 group. In this process, we will discuss the Clemenson reduction. Clemenson reduction is zinc amalgam in the presence of in the concentrate HCl. Bose-Christian reduction is in the presence of base and hydrogen. Reduction of hydride transfer reduction by lithium aluminum that we have already discussed. Also you can see here the carbonyl group in the presence of lithium aluminum hydride converted the corresponding alcohol. Here the mechanism is here. This is carbonyl compound in hydride and transferred to carbonyl carbon center and form accordingly with this anionic form. Then another carbonyl compounds come, then another hydrogen hydride transfer from the aluminum CH bond and corresponding 4 hydrogen can transfer here and finally corresponding alcohol form. This is another sodium borohydride reducing agent. By the sodium borohydride reducing agent also you can see the mechanism here. The carbonyl compound sodium borohydride, the hydride and transfer to the carbonyl center and carbonyl O negative form which take the proton from the solvent and form the corresponding alcohol. So 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 we will discuss accordingly. Okay, thank you. Next example also we will take some specific reagent.